given points. So if I want to approximate the instantaneous rate of change, I can use the average rate of change that is closest to that value. So in other words, in this case, what you need to do is use the instant average rate of change for the 2 points that are closest to 1/2. So what 2 points are closest to 1/2 in this case?
1/3 and 2/3.
So you will use the average rate of change on the 1/3 and 2/3, the 2 points directly on either side of 1/2 in the given chart. Yeah. So, and that's a pretty common thing that they tend to do. Anytime you're approximating an instantaneous rate of change to a derivative, you're using the secant slope of the 2 points, and it has to be the 2 points closest to the point. So you cannot use like 0 and 1, for instance. A lot of people tend to do that. If you use 0 and 1, that's too far off with our given information. Now, if in the chart the closest points were 0 and 1, that'd be perfectly fine. But in this case, we have 2 points that are closer to that, so we can kind of get a better idea. Remember, when we talked about finding the instantaneous rate of change of the derivative, you move those 2 points as close together as possible to get the exact answer. Well, if we can't move them on top of each other, we still move them as close as we can possibly to them. And in that case, the closest we can get are 1/3 and 2/3. And for those of you to write down an answer, so you can either rework it or go back and make sure you get the right answer. The answer is -9. You do have to indicate units of measure. So what would r prime be measured in?
Gallons
per hour squared.
Gallons per hour squared works. You may also do gallons per hour per hour. Apparently that was funny. Okay.
Yeah.
Remember, it's a slope, so just take your function here and divide it by your t. So gallons per hour divided by hours, which is gallons per hour, or gallons per hour squared. Okay, moving on to part B. Using a left Riemann sum, which hopefully should be pretty easy. So our answer here, so those of you can check it that have completed the problem, it is 8 gallons is your answer. So gallons is the unit of measure, and the answer should have been 8 numerically. Do I need to show anything out for that one? I gave you a little hint also. Apparently Deborah's not here to speak up for those of you that need questions, so you'll have to speak up yourself. So does anybody need me to show anything out on number 1B for a left Riemann sum?
Yeah, actually, I do need help with that.
Okay, what part, Miguel? Help me to help you and not just show you the answer. Where's the trouble come from?
Like what to do. I don't know where to start really.
Okay, do you remember what a Riemann sum is?
It's when you split it up into smaller pieces. I don't remember the correct terminology.
Riemann sum is just the use of rectangles.
Oh, yeah, okay.
So we had 0, 1/3, 2/3, and then 1, I think were the values, right? That was going up by that. Okay, so we have what, 11, 8, 5, and 0. So remember, you should, if you need to, definitely be drawing this 8, 5, and 0. So 0, 11, 8, 5, 0. So I don't care if the points are accurate or not. This is just a graphical representation for me to be like, hey, this is what this kind of looks like. And then we're going to use, so those are my 4 data points. I'm going to use those to construct my rectangle. Since we're using the left Riemann sum, I will use the left points to make my rectangles. So in this case, my first rectangle goes from, our marker doesn't work at all, does it? That's god awful. I don't think I've ever used that once. So your first rectangle will go from 0 to 1/3, and it will have a height being on the left. So you draw your base, draw your height, and then make a rectangle out of that. Your second one will have, again, that's your width. In this case, my height goes up to the left point. Make my rectangle. Rectangle, rectangle. So in our case, they are all values of 1/3. This one has a height of 11, this one has a height of 8, and this one has a height of 5. So just find the areas and add them up, so you get 1/3 times 11 plus 1/3 times 8 plus 1/3 times 5.
Okay.
Remember, Riemann sum is just a fancy terminology for rectangles. So you're just adding up a bunch of rectangles. And because we're using the left Riemann sum, that's why we use the left points. If they'd asked us for a right Riemann sum, we would have used the right endpoints. Does that make sense now, bud?
Yeah.
Anybody else, any questions, clarifications? And again, don't forget they did say indicate units of measure again, so make sure you're putting that. So remember, when you integrate, you're multiplying those units. So you do gallons per hour times hours. So the hours would cancel out there, giving you gallons. So don't forget that. If you're doing a derivative, you divide them. If you're doing an integral, you multiply them to get your units. All right, part C, hopefully should be really easy. What's the antiderivative of r prime of t dt?
RT.
R.
Yeah, it's just r. So the integral from 0 to 3 is just r of 1/3 minus r of 0. And they give you those values in the chart. So that should hopefully have been relatively easy. So you get 8 minus 11, which is -3. And they do not ask you for units or anything like that, so you just need -3. If you want to put units, make sure they are correct. That would be gallons. Okay, part D. All right, so what do we know from looking at that formula in summation notation, which is something we looked at for the past, I think, either at least yesterday, if not day before, I don't remember. So what information can we get from that to help us write our integral?
1/4 is
The
the start
starting
value.
point.
So what is the starting point, Miguel? Do you agree with, I think that was Thomas?
Yeah, I do.
Okay, so 1/4 being our starting point, I'll agree to that. So what is our ending point then? How do we find that?
I don't
So
remember.
So was that Anand?
Yeah.
Yes, that is correct, sir. So where do we get that from, though?
From the original problem.
No, not from the original problem, unfortunately. So we don't know anything on the original problem exactly where the answers are. We're just trying to write an integral. It could be the values from the original problem. It may not be. Specifically, we know it's not because it starts at 1/4, and nothing in our original thing has 1/4. But we can get the b minus a from something in the problem that they gave us.
1/2n.
So that 1/2n. So they did try to trick you a little bit if you're not paying attention on this one. With that being 1/2n, that is not what we're used to seeing. We're used to seeing it as just something over n. So we have to realize that 1/2n is equal to b minus a over n. So a couple of things here you can do to kind of figure this out. You can multiply both sides by n or whatever. It doesn't really matter how you want to do it. But what you could realize also is this side is 1/2 times 1/n, which is 1/2 over n. That's where they were trying to trick you. So b minus a is the 1/2 part. So you want to try to make it look like that form. The alternative to that is you could multiply like by n would also work. So those all cancel, and you'd be left with 1/2 equals b minus a, because these just cancel out. So you could do it either way, however you want to see it, and kind of look at it that way. So our b minus a is 1/2. So we figured out that our a is 1/4. So what is our b value? What's 1/4 plus 1/2?
I can't math right now.
3/4.
Thank you. Yes, 3/4. Now, the last question we have to ask ourselves is what goes inside of our integral? This is where we have to go back and remember that when we talk about our integral of f of x dx, it is the sum f of a1 plus k delta x times delta x. So this is our basic idea of what the Riemann sum looks like when we do our integrals. We right now have the summation of r of 1/4 plus k times 1/2 over n. So now we want to go backwards. So we've matched up those two things. We matched up those two things to get our delta x and get our b and a. Now we have to realize is we need to match up those two things. So going backwards, that will be the integral of r of x dx. You can call r of t dt. That part doesn't really matter. But we have to realize that all it is just the integral of this r function that we have sitting out in front. So r of x dx. That is not the easiest thing to catch. When I was looking at it earlier this morning, I looked at a different problem similar to it. I missed the r completely. And I was trying to figure out what the inside was, and so I was not paying attention, so you do have to be careful and pay attention there. But you definitely, on some sort of formula sheet somewhere, want you to write down that top line to help you if you do get one of those problems. Does it make sense how I correlated all those pieces together, hopefully?
Yes.
Okay, so again, as a reminder, you guys need to be making sure you have these sheets that you're making notes, and then you're going to want to consolidate and make it look nice and pretty and have it all in one place so that you're not having to hunt and search through 1,500 pages. You got it in, I don't know, a formula sheet shouldn't be any more than 2 to 3, well, maybe 4 to 5 pages for this stuff, depending on how big you write and everything. So everybody pay Abby $5 to make her write you a sheet. She'll get it done in like a half a page.
But then I can't read.
Break out the magnifying glass, bro.
That's what I wear glasses for, and they still don't work.
Get stronger glasses. I don't know what to tell you. Put it on the computer and use the magnify image 500%. Any questions on what I did on any part of this problem? Please make sure you're asking. Don't waste your time sitting here doing nothing. Okay, moving on to number 2 then. They give us a nice little funky graph. And they give us the areas. Okay. Find the value of 0 to 7. Okay, so anybody want to share their answer to part A? Before I just randomly pick on someone?
That graph confused me.
How? Like what part of it confused you?
Just looking at it, I don't know all of this.
Oh, I mean, you're not ever actually doing anything with the graph, it's just a funky looking graph. Okay, so looking at A, what does it mean? What is the integral from 0 to 7 f prime of x dx? What does that mean?
The area under the curves.
Okay, so what is the integral from 0 to 7 of f prime of x dx?
-1.
-1.
Yay! They gave you the areas, they just want you to make the connection that the integral means the area under the curve.
If I know nothing else, I'll at least know that.
I hope you will know that because that is part of the fundamental theorem of calculus. If I
Yeah.
did not get the fundamental theorem of calculus through, then I did some seriously bad teaching. Like everybody should know FTC. Okay, so part B. Oh, they're giving me F of 4. What does that mean I'm probably going to use?
The fundamental theorem of calculus.
Oh my god, I'm going to use the fundamental theorem of calculus. Um, okay, so this one is a little bit trickier. It's not just straight up fundamental theorem of calculus. It's close to it. It does use the idea of fundamental theorem of calculus. I will give you a hint, and as you're writing things down, because this is something that is definitely possible to appear on your test, if it says write an expression that involves an integral for a function, that means one of your bounds is going to be a variable of some sort. Now, it could be a very basic variable like x. It could be other stuff. Can't really say for sure. But if you see it says a expression involving an integral, that typically means you're going to use a variable as one of your options, as one of your endpoints. So they gave us f of 4, so I'm going to use f of 4, just like we've talked about. We are looking for f of x. So if I have f of 4, 4 is going to be one of my bounds, and I'm looking for f of x. So what is my other bound?
X.
X. That's how you know what your bound is x. When they say they're looking for f of x. So before they would have gave you f of 4 and asked for what is f of 7. Now they've given us f of 4 and they're asking us for f of x. Well, what am I going to take the integral of to have my answer be f of x?
Oh, the derivative probably?
Very good, yes. F prime of x dx. And then we also need to subtract the f of 4. A couple of things to point out. Some people don't like the fact that I used f of x on the left. So people don't like the fact that this x and this x match this x. These x's inside do not matter. I can replace them with any variable I want. Let's have Ashley pick a letter. Any letter you want.
Oh yes, thank you, Ashley.
Oh, sorry, I had to get all the way back to the whole push to talk. But anyways, just use teeth because we use that like all the time, you know.
That is perfectly fine. Yeah, use teeth. Oh, I don't like teeth. Nope. Hallie Kate, pick a different letter.
Oh yes, thank you.
Miguel, give her some time.
You gave her like 3 seconds. Oh, Hallie Kate.
Can you hear me?
Sort of, yes. Pick a letter.
H.
H. Okay, I'll stick with H. I don't like H. I'm changing H. I like S.
Pick Q.
Q? Okay, Q, fine. I'll change it to Q. The whole point of this is, does it matter what letter I put here?
No, it's a dummy variable.
Thank you. It doesn't matter. They could be X's, they could be T's, they could be Q's, they could be H's. You can pick whatever you want as long as the two of them match up in this case. God, I need to get new markers today. So I don't care what letter you put there. I put X's because I'm just used to X's. It doesn't matter that it matches this one or not, but that's perfectly fine. And they do want an expression for f of x, so we do have to solve for f of x. I can't write you no more. You're annoying me. I'll write everything in red now, apparently. So f of x is equal to, I'm going to add this over so you get the integral from 4 to x, f prime of, use q's. Q dq plus f of 4. And there is your expression for f of x with an integral. Does that make sense to everybody, hopefully, how I did that?
Yes.
Yes.
Okay. So again, you should be making notes to yourself off to the side to then consolidate to a formula sheet of some sort. If they ask you for an integral, an expression involving an integral, especially for a function, That is pretty much how you do it every time. It's not going to be any questions. You use the point they give you, then what they're asking for. They gave us f of 4. They're asking for f of x. So x is going to be one of my bounds. Okay, then we're going to have to use that to find absolute minimum and absolute maximum. Okay, well, how do I find an absolute maximum and absolute minimum? Don't all answer at once or nothing.
Do you still just use the first and second derivative test?
No, we do not use first and second derivative tests. Can anybody explain why we are not using the first and second derivative tests?
I'm guessing because it's the absolute.
That is correct. First and second derivative tests find relative.
Oh yeah.
We have a little bit slightly different. It involves some of the same steps, but we have a slightly different method for finding absolutes. And again, these are things we should have noted somewhere, as I'm trying to give you guys hints. You should write down, to find absolute maxes and mins, do this, and have a step-by-step list. That's perfectly fine things to do. So how do we find our absolute maxes and mins?
I don't know.
You take the endpoints of your interval, and then you take the critical values from f prime and you plug it into f of x.
There you go. So the critical values is the same thing as the first derivative and second derivative test. However, we can't forget we have to test our endpoints. Well, if I need critical values, how do I find critical values?
First derivative.
Take first derivative. So, well, I need the derivative of my function then. Okay, well, it means I have to take the derivative of this whole thing. Well, what's the derivative of the left-hand side? It's not rocket science, guys. What's the derivative of the left-hand side?
Oh, f prime of x.
F prime of x.
Thank you.
Okay.
What's the derivative of the right-hand side? So I'll make these. What's the derivative of f of 4? What's the derivative of f of 4?
0.
0. What's the derivative of this lovely integral we have right here?
F prime of q dq.
No. What happens when you take the derivative of the integral? The integral and the differential disappear because they cancel. All that cancels out. Plug this in.
It would be lowercase f of x minus f of 4.
I don't think that helped us very much.
No, yeah, I don't know. I'm confusing myself.
Well, you can use the graph because the graph is f prime.
There you go. I was waiting for somebody to say that. If you take the derivative of this lovely function, you're taking the derivative of f of x. What's the derivative of f of x? F prime of x. F prime of x equals f prime of x. So that didn't help us any. We have to remember they gave us a graph of f prime. We already have that information for f prime. So this function here, taking the derivative, actually doesn't do anything. You just want a big circle. However, we do use the graph to find our critical points and our endpoints, obviously. Our endpoints were what, 0 and 8? Isn't that what it is on this one?
7.
0 and 7. Critical points. How do we find our critical points again? What are critical points? Or critical values, whatever you want to call them. Somebody, the definition of our critical points or critical values?
Oh, whenever it equals 0 or undefined.
What did Miguel just do?
It, whenever the function.
Whenever the function? Which function?
F prime equals 0 or undefined.
Okay, so we're f prime, because we're analyzing f, where f prime is either equal to 0 or undefined. It's not undefined anywhere, however, it is 0 at 1, 4, and 6. It's also 0 at 7, but we've got 7 included in our endpoint. I said, what, 1, 4, and 6? Yeah. So we get our critical points and our endpoints, and then we plug them in. So f of 0, f of 1, 4, 6, and 7. So you get those and you plug those in and evaluate them based on the function we've written above, and then we find our max and our min. So the first question is, we have the integral from 4 to 0. What is the integral from 4 to 0? integral from 4 to 0. So somebody help us out. What's the integral from 4 to 0?
I don't know, Chief.
I'll give you a hint. Look at the graph. What does integral from 4 to 0 mean? You are very quiet, Miss Bridget, but yes, that is correct. So it involves the area under the graph, just like we did with part, what was that, A? So it's asking for what is the area from 4 to 0? And that answer will be
2.
how'd you get 2?
Negative 5.
I looked at the wrong thing. Never mind.
Okay. I was like 2. So you got negative 5, Miguel. Is that what you said?
Yeah.
All right. Do you agree with Miguel? Is it negative 5?
No,
Why not, Nolan?
because your x values need to be switched, so it needs to be negative.
So you can switch them if you want to switch them, or you can just make the correction that if I'm going backwards, everything is reversed. So normally that 7 underneath would be negative 7. However, since I'm going backwards, that's actually positive 7. And the 2 will be negative 2, so the answer will be 5. You do have to be careful. And then they told us what f of 4 was 10. So this will be 5 plus 10, which is equal to 15. Now on the rest of them, I'm not going to write out the integral. And my suggestion to you is on the AP test, I would, just to be cautious, probably write out all of them. However, you need to at minimum write out at least one. Don't just write f of 0 equals 15. If you do that, you may end up losing a work point. You need to at least show one of them. And then on the rest, I'm going to show the numbers I'm adding together as well. So now that we know that, hopefully it should help us kind of move things along a little quicker. What is the integral from 4 to 1?
7 plus 10 would be
positive 7. Very good. Plus 10. What's the integral from 4 to 4? Someone who hasn't answered before I have to call on you. Hey, look at that. Valeria's trying to talk. I'm calling on Valeria. Valeria, what's the integral from 4 to 4? Oh, you can't just go quiet, Valeria.
Hey, can you not hear me?
We can now.
Okay, sorry.
You're fine. What's the integral from 4 to 4?
Answer that I'm really wrong.
It's a really easy question, I promise.
Would it not be? I just.
I didn't hear what you said if you said something, so I'm sorry. Say it again.
Would it not be 0? I just.
Oh, yeah, I didn't hear that, so if you said I'm sorry. Yes, it's 0. So you get 0 plus 10. What's the integral from 4 to 6? Somebody? Anybody? Hopefully it should be getting quicker and easier.
3.
So you get 3 plus 10. I'm going to hope you're right. And what's the integral from 4 to 7? Anybody? 4 to 7? 4? I think that was Will. Okay, you're just really quiet. You're fine. So yeah, okay, yes, I agree with those values. Okay, so then you just find your max and find your min. Make sure to pay attention to the question they asked. They said find the absolute minimum value of f. What does that mean you're looking for? What does it mean if they want the absolute minimum value of f? What are they looking for as far as your answer?
The smallest value.
Define the smallest value. Smallest value of what?
F of x?
But what is that? How do I know what my answer is? Looking at all the work we've done, what is my answer?
A y value.
There There you go. They're looking for the y values that you just found. Now they can say where does the absolute minimum occur, and if they ask you where it occurs, what are they looking for?
An X value.
They're looking for an x value. You have to be careful and answer their question. Remember, we've talked about this a little bit when we were doing these questions. An easy way to answer both questions regardless is you could say it has a min of 10 at x equals 4. That statement answers both questions. What's the minimum value? Where does it occur? And then you can have a max of 17 at x equals 1. Again, answers both questions. What's the maximum value and where does it occur? If you write it like that, you don't have to question what they're looking for, but you definitely want to make sure you have answered their question. If you've not answered their question, you're not going to get full credit. And your justification, when it asks for a justify, that work over there is your justification. That is perfectly fine for a justification. Okay, so any questions?
No.
Okay. All right. Moving on to part C then.
Is C as straightforward as it seems, or is it
Yeah.
right there?
Yeah.
No, it's okay.
And to be honest, with this year's test, I wouldn't doubt that there will be maybe not such a basic question, but there may be some kind of basic antiderivative question in there. If they make everything super difficult this year, that's very hard to get cutoff scores and things like that. So they probably, I would assume, like your 25-minute question will probably have some basic parts to it as well. I don't know if it'll be quite this basic.
Yeah, this took.
Because I mean, you could have this written down on a formula sheet basically. But I wouldn't be surprised there's some sort of basic integrals with a u sub and something in there somewhere, to where it's not all super convoluted, complicated. Oh my God, because they have to be able to find where points are given and things like that. As far as exactly what they're doing, we may find out a little closer to the test day, as far as how points are being distributed, but they have not said as far as I know yet. So yeah, everybody should have gotten 5 right, or C right. So 5x minus 1/3 x cubed plus C. Don't forget the plus C. And then part D probably tripped a couple of you up.
Yes.
This is the kind of, part D is probably what I would anticipate as far as for the question that would be your basic antiderivative, because this one is a pretty straightforward one. What you have to realize, if you make one small adjustment or one thing, actually that's the first step of the problem, it becomes a lot easier. So if we do integral from, what was it, like 2 to 4, something like that, what's the inner bounds?
1 to 2.
1 to 2, okay. X f prime of g of x dx. So if you make this one step, this problem becomes a lot easier. You get, if you switch out g of x for, what is it, 5 minus x squared on this problem, right?
Yeah.
If you make that one substitution in my opinion, this problem becomes a lot easier to understand and deal with. Something else you can do that'll help you move things over is you can also move the x over here, so you can do the integral from 1 to 2 of f of 5 minus x squared x dx. And hopefully what you should be realizing at this point is, here's my u, here's my du. That's the kind of the idea there. So you get u is 5 minus x squared, and then du ends up being negative 2x dx. Move the negative 2 over, so you get negative 1/2 du is equal to x dx. I would anticipate any integral you do by hand, if they have you do an actual integral like an antiderivative like this, will be a u substitution. I doubt it'll be anything less than a u sub. So always be looking for that u and du. Now, could they give you something super basic as it's just a, hey, here's a free point for everybody if you know how to take an antiderivative? Possibly. but I don't think they're going to go that far. I think it's going to be something like this where you got it relatively easy to spot u and a du. So then plug everything in, and you get f prime of u, bring the negative 1/2 out front, and then x dx turns into du, and 1 to 2. Guess what time it is?
It's 10:41.
It's time to play everybody's favorite game of Find O'Donnell's Mistake.
Damn it!
Is it your bound?
Oh man, you ruined it, Thomas. You did it too fast. Yeah, that's my bounds.
Boy.
Why are my bounds wrong?
They're not the U's. They're not the U bounds. They're the X bounds.
Very good. That's a very common and easy mistake to make. Once you switch to U's, you need to switch your bounds or leave your bounds off and switch back to X's. I highly suggest the first one. Change your numbers. It'll be a lot easier. So how do I do that? So how do I get my correct numbers for my bounds?
You plug them into where you substituted the 5 minus x squared to the U and get your U.
Yep, so use your formula that you have right here. So you know x is 1, so you get, so u of 1 is equal to 5 minus 1, which is 4, and u of 2 is equal to 5 minus 4, which is 1. So we get, our bounds are 4 to 1. Also be very careful, make sure you do not switch them to make them in the proper order. You have to replace them for whichever value they were. So 1 goes to the 4, 2 changes to the 1. Don't make that from 1 to 4. And then you evaluate this pretty much any way you want. So I would say this is equal to negative 1/2 f of 1 minus f of 4. And then whatever f of 1 and f of 4 are, I'm assuming that at some point they've given them to you. We have f of 4. Do we have f of 1?
Do we have to use it from the previous problem?
You have to use the f prime that we've been using, yeah. So I guess we'll have to use... Are they really going to make us use that? So we'll have to use our function that we wrote on the previous problem, it looks like. That's a pain in the butt. But yeah, it's not too bad because the f of 4 part's really easy. So if we use our function that we've written for f of 1 above, so you get negative 1/2 integral from 4 to 1 of f prime of x dx minus the integral from 4 to 4 of f prime of x dx. The really nice thing is that from 4 to 4 goes to 0, and we've already done the integral from 4 to 1 if I remember correct. And if not, you can look at it very easily. I think that's what, negative 7? Yeah. So you get negative 7 and negative 1/2. So the answer is just positive 7/2. Oh, hold on, they got negative. How'd they get negative? Okay, that would have been a positive 7, not a negative 7. From 4 to 1. So be careful there. So you do have to use that function we wrote above. Any questions on anything I did there? I know it's a little involved problem for a little bit.
So you just don't sub u back in?
No, you never have to sub u back in if you change your bounds. If you don't change your bounds, then you have to sub u back in.
Okay.
I prefer to change my bounds. because you're doing the same calculations either way. It just saves you a step of writing out. And I'd rather not have to plug in 5 minus x squared back in. It's easier just to leave it as you use. Any other questions? Alright, moving on to part B then. I'm gonna score Annabelle's this time. She's not even here. Giving her all zeros. Alright, so this is calculator enabled question. Great. They give us f of x is cosine of the square root of x. That's terrible. Approximate the definite integral using a midpoint Riemann sum with the subintervals of 1, 1.6, 1.62, 2, 3. Okay, so what does it mean to use a midpoint Riemann sum? Depends on what you mean by that, but possibly.
Well, I mean, like, I don't know how to explain it, but like, the heights for the rectangles are the take the midpoint of the rectangle and like side.
Sort of. So we have our 1, 1.6, 1.62, and 2 and 3. If we're using a midpoint Riemann sum, our height is determined by the points right in the middle. So last time it was determined by the left or the right, and I don't know where any of these rectangles actually are. This is kind of just a general overview. Remember, then you make your rectangle like that. And let's just make this one, really short, because I have no idea where any of these rectangles are. Could be something along those lines. I don't know what my height values are at this present moment. We can get them from the calculator, no big deal. But that is generally how you would look at a midpoint Riemann sum. Now, depending on what the height values are, yes, it could look different. I have no idea if I'm even right on those values or not. But to set the problem up, we have to realize my first rectangle has a base of 0.6. So 0.6. My height is my function value at 1.3. I guess I don't need that one. My second one has a base of 0.4. And my height is f of 1.8. And my last one has a base of 1 and a height from f of 2.5. That is your basic midpoint sum. Now, the only thing we have to do to be able to get full credit for this is just figure out what your function values of 1.3, 1.8, and 2.5 are. You can get those from the calculator. And you really don't even have to do that. Remember, this is free response. So if I want the value for 1.3, it's 0.6 times cosine squared of 1.3. This one's 0.4 cosine square root of 1.8. And this one's 1 cosine square root of 2.5. And remember, you can leave it just like that. Please leave it just like that. There is no reason to simplify that out for any reason whatsoever. Now, if you need to use that on a future part, you can simplify it there and put it in the calculator, but that is worth 100% credit right there. And in case you want to check your answer for anybody who did it, it's 0.331. But yes, leave your answer just like that. No reason to change it.
Say less.
What'd you say?
I always forget that you could always do that.
Yeah, do that. Leave it just like that. And remember, I get your AP test this year, so I get to yell at you.
Oh, Jesus, I'm not ready for that.
Oh, it's going to be a bad yelling. I will yell at all of you.
Oh, I know it.
Even if you get 100% correct, I'm still yelling at you. Just for funsies. Alright.
100%, you meant 0. Haha.
I swear to God, anybody gets nothing right on this test, I really will find you and put my foot up your butt. You all know something.
I have the derivative of 100.
Alright, part B. Approximate the definite integral using a trapezoidal sum
Oh Jesus.
Oh,
Yeah, these are
Jesus.
bad.
What is the trapezoidal sum?
Making trapezoids.
I mean, it's not wrong.
That's
So at that point, when we go to do our trapezoid sum, the graph is still relatively the same. I just don't need these middle values anymore. So my kind of sketch will be the same. So at this point, you find your value for 1, 1.6, 2, I'm going to make that right there, and 3, I'm going to make that there. Why not? I have no idea what these are. So once you get your points, you just make trapezoids. And remember, the area of a trapezoid is 1/2 height, base 1 plus base 2. Yeah. So don't forget that. At that point, you just fill everything in. Remember, your height value is your width here. Those are your heights. In this case, your bases are the parallel sides, so your bases will be those values. So the area of this first trapezoid has a height of 0.6, so 0.6. Base 1 is f of 1 plus base 2, which is f of 1.6. So this is your trapezoid number 1. So this is 1, 2. So that's 1. The area for 2 then becomes 1/2. That's got a height of 0.4. And base 1 is f of 1.6 plus f of 2. And then the last one is 1/2 1 f of 2 plus f of 3. And then, of course, fill in your function values and stop there. Do not go all the way out and simplify these all the way down. There is no point in doing that. Please do not do that. For those of you that want an answer for this part, the answer is 0.342. Okay. Questions on that one?
No, it'd be making sense.
Good. Part C, it is known there's your first and second derivatives. Great. Would a trapezoidal sum approximation for that be an overestimate or an underestimate? So we've talked about this a couple of times. How do we tell if something is an overestimate or an underestimate for the trapezoidal sum?
Specific to the trapezoidal sum?
Yes. So, well, we've done it with Riemann sums. We've talked about it with Riemann sums and everything, but we want to talk about it with being a trapezoidal sum. So, to be honest, for that, what we really want to do is we want to get proper values for your function because it'll help out a lot actually seeing what the actual function looks like because then we know what we're looking for. But in general, what do we need to look at in order to tell if something is an overestimate or an underestimate for these?
Whether the function is increasing or decreasing.
So increasing and decreasing. However, what else did they give me? So increasing and decreasing obviously is from how do we get that information?
They gave us a second
Just-
derivative.
So, but how do we tell increasing, decreasing?
Oh. Positive derivative, negative derivative.
So the first derivative. But they also gave me the second derivative. That leads me to think that I might need to do just a little bit more. Whether that's true or not, I don't know. But it's possible we might have to do a little bit more. So that's why, like I said, looking at the actual graph, which we do have, and this is a graphing calculator enabled question. I've just got to pull mine up to see what the values are. But you really want to look and see, do I need the first derivative? Do I need just the second derivative? Do I need both? Why did they give me both? They may have just given you that second derivative just to throw you off. So let's see, cosine. Squared. I'm going to look at the graph of this. So change my window from what we're doing from 1 to 3. So x window from 1 to 3. I have no idea what my y values need to be, so I'm just going to make that negative 10 to 10. That should more than cover it. She's only go from 1 to 1, so I don't even need negative 10. But I do negative 2 to 2. And then we're going to graph cosine square root of x. Alright, and we go to graph it. Let's see what it looks like. I'm in radio. Well, it's basically a straight line from the looks of it. It's obviously curved a little bit, but it's definitely a decreasing function. So we're going from what, 1 to 3. It crosses right about there. So it looks somewhere around there. That's kind of what the graph looks like. So if we're using what does it tell us? Just a trapezoidal rule, we have to ask ourselves what's going to happen there based on that. So we know the first derivative is negative. It's a decreasing function. But that doesn't necessarily help us as far as if it's an overestimate or an underestimate. Because if I use this point here and this point here, well, I know it's a decreasing function. That part doesn't matter. The question is, which way does it curve? So for instance, I'm going to exaggerate it. If I'm concave down like that, then my trapezoidal rule becomes a overestimate. However, if I am concave down, then what is my trapezoidal rule?
Underestimate?
It's an underestimate. So here, the fact that it's increasing or decreasing doesn't matter. I could do the exact opposite to kind of show what happens if it was kind of the opposite way, like that. So if it was an increasing function, again, if I have my two lines there, if my graph is in concave up versus concave down, so at that point, my trapezoid is going to do the same thing that my function does. It's going to be increasing or decreasing. So at that point, the only thing that tells me that I need to know the second derivative. That's why the second derivative is important. The first derivative actually doesn't end up telling us much of anything here. So we have to look at the concavity. So again here, if this function, if the graph is concave up, then we know my trapezoid is an overestimate. If it's concave down, my trapezoid is an underestimate. So this all relies on the second derivative, not the first derivative. So for rectangles, and again, as you make notes to yourself, because this is a relatively good thing to have, for Riemann sums with rectangles, then you do increasing, decreasing. That's the first derivative. For trapezoidal rule, overestimate, underestimate is determined by concavity, second derivative. So I'll repeat that again because people should be writing this down. For Riemann sums with our rectangles, first derivative, increasing or decreasing, tells you overestimate versus underestimate. For trapezoidal rule or trapezoids, the second derivative, concavity, tells you if it's an underestimate or an overestimate. So in this case, because we have the second derivative, you look at the second derivative and it is concave up. So if our graph is concave up, what do we know about our trapezoid? So looking at the pictures I have on the board, if it's concave up, is our trapezoid an overestimate or an underestimate?
Overestimate?
Our trapezoidal rule is an overestimate because the second derivative is positive, is concave up. Anybody have any questions on that? Again, I don't necessarily think anybody probably got that correct. Did anybody get that correct on their own?
No.
I'd be kind of shocked because it's not something that's just blatantly obvious.
And the reason for our answer is because of concavity.
Yep. So all you gotta do is say that the graph of, at some point you should say it's concave up the entire time. You would use the second derivative to do that because they gave you the second derivative. You can graph it. You don't have to do that by hand or anything at all. Just look at the graph and be like, oh, it's concave up. You don't have to justify why it's concave up because you have a graphing calculator. They expect you to plug that in the graphing calculator. All you have to say is, oh, f double prime is positive, therefore it's concave up. So you can say the graph is concave up the whole time. And then you would say the trapezoidal sum is an overestimate because the graph is concave up. Okay, I'll do D real fast, that way we can do ace math tomorrow. Right, integral as a limit of Riemann sum with n subintervals of equal length. So hopefully that shouldn't be too hard for us now that we've done this a few times. Oop, I think timed out, crap. It was integral from 1 to 3, right?
Yes.
So this is just using that formula that we have written down because we all wrote it down earlier, right? Will, are you still in bed?
I'm on my bed.
Yes.
I'm also on my computer.
So the part that we don't typically tend to write out, though, is we do the limit as n goes to infinity here. We tend not to write that out, but we do need to have that if we're writing out a full integral. So we have f of, our starting value was 1. It's 1 to 3. Yeah, okay. So 3 minus 1 is 2, so it's 2k over n, 2 over n. And then we can do, from k equals 1 to infinity. I don't think the infinity is right. Hold on. Yeah, that should be right. Should be infinity. That's a terrible infinity. That's an 8. And I'll log back in real fast. But that should be, parts of it should be relatively easy for us to get. So the 2 over n, we should all have that. That's not a big deal. That's 3 minus 1 over n. The 1 on the inside, f of 1 plus 2k over n, that should be pretty easy. The stuff that we probably would forget and make our mistakes on would be the limit notation out front, and then the infinity part. Let me double check and make sure I didn't make any mistakes on that. Part B. I feel like something's off with the 1 to infinity, but I don't think so. Oh, they put an n up there. Yeah, that's fine. N's fine. So we shouldn't have the infinity on top. Technically, it's infinity because this n goes to infinity. That's what I'm used to. There we go. So 1 to n. So the limit part and the f to the n part is the part that we probably would have made a mistake on. But the inside part, you should be fine with. And they do actually apparently want the function written in there. So they want you to put the cosine part in. So that's not too bad. So since they gave us f of x, they want you to have it the limit as n goes to infinity, sum from k equals 1 to n of cosine square root of 1 plus 2k over n, 2 over n. They want it like that. So parts that we should be able to get because our formula from earlier, you should have been able to get the 1 plus 2k over n, the 2 over n. The part we had to remember outside is that we are doing an infinite number of sums. That's what a limit means. So it's a limit as n goes to infinity of the sum from 1 to n. I don't quite think that'll be on the AP test, but you never know. So you should be having things like that kind of written down. All right. Any questions of anything before we close class for the day? And before anybody says anything or leaves, as a reminder, your ACE Math will start going over it tomorrow, so make sure at least part of it is done.
Yes, sir.
Yep.
All right. So any questions or anything for me from anybody?
Can I go back to sleep?
I don't care what you do.
Thank God.
I have a conference call with my tax guy, in like the next 20 minutes, so I may be a little late to physics.
You're okay, buddy.
Okay, I just wanted to, let you know.
You're the only one who shows up. I'll give you some leeway, bud.
Thanks.
No problem. I'll talk to you guys tomorrow. If you have any questions, feel free to message me.
Alright, see you done.
Okay, bye.
Bye. No, I will not explain any problem.